Welcome to the first video in Unit 2. Today we are going to talk about Lesson 1, Properties of Sound Waves. How is sound produced? If you look at this figure, you will find out that when I vibrate this tuning fork, there are a lot of compressions and rarefactions are produced as a result of vibrating of the tuning fork. But if I stop vibrating of tuning fork, you will find out that there is no sound. So we can deduce or we can conclude that sound is produced due to the vibration of bodies, and it stops when the vibrating bodies stop vibration. You are listening to me, so can you imagine? How can you hear me? Well, I will tell you. My voice is acting as a stimulus, which stimulates or fosters your ears in order to hear me. So, from the previous knowledge, we can deduce the definition of sound. Sound is an external factor or stimulus that affects the ear, causing the sense of hearing. The nature of sound waves. Sound waves are mechanical longitudinal waves. Can you tell me why? Can you give reason? Okay, I will tell you the reasons. Firstly, sound waves are mechanical waves because they need a medium to propagate through, medium such as air. At the same time, they are longitudinal waves because the medium particles vibrate in the same direction of propagation, forming compressions and rarefactions, as we have learned in the previous slide. 2. Sound waves propagate through media as spheres of compressions and rarefactions, whose center is the source of sound. Okay, let me explain this point. If I vibrate the tuning fork over there, you can imagine that spheres of compressions and rarefactions are produced as a result of vibrating the tuning fork. You can use the previous slide in order to solve this question. Give reason. We hear sound from all directions that surround the sound source. The answer will be because the sound travels through air as spheres of compressions and rarefactions, whose center is the source of sound, as we have learned. 2. What is meant by the wavelength of a sound wave is 1.5 meter? The answer will be this means that the distance between the centers of two successive compressions or two successive rarefactions in such wave is 1.5 meter. I will tell you a good mechanism to follow in order to solve this type of questions. If you have what is meant by question, you can define wavelength, then you attach this number to the definition of wavelength. I think it's a really good mechanism to follow in order to solve this kind of questions. Velocity. Sound travels through air at a velocity 340 meters per second. It may exceed or become less than this value. We can calculate the wave velocity by using waves propagation law. Sound waves velocity v equals frequency f times wavelength lambda. Some problems. Sound waves are produced from a vibrating tuning fork of frequency 512 cycles per second. If the wavelength of these waves is 60 centimeters, calculate its velocity through air. Firstly, you need to focus on the values of frequency and wavelength in order to solve this problem. And then you should write down the law of wave propagation, which is sound wave velocity v equals frequency f times wavelength lambda. Let's talk about audible sounds, and let's differentiate between musical tunes and noises. If we start with the definition of musical tunes, They are tones of uniform frequency and comfortable to be heard, like this sound. And the examples are clear. Number 1 is violin, number 2 piano, number 3 reed pipe. If we talk about noises, they are sounds of non-uniform frequency and uncomfortable to be heard, like this sound. And examples are so clear too. Number 1 drill, number 2 loudspeakers, and number 3 horns of cars. To relate science to our daily lives, so we have a real life application, which is earplugs. Earplugs made of silicone are sold in pharmacies. They take the shape of the external ear canal, where these plugs are used to avoid the hazards of noise in loud places. At the end of this session, I want to thank you so much for good listening and see you next time in part 2.